Welcome to our channel. Today we're diving into the extraordinary life and groundbreaking achievements of one of the greatest minds of our time, Stephen Hawking. His journey through the cosmos wasn't just theoretical, it reshaped how we understand the universe itself. Get ready to explore his pioneering work, from black holes to the Big Bang. Don't forget to hit the like button and subscribe for more mind-expanding content. At just 20 years old, Stephen Hawking embarked on an extraordinary mission to uncover the secrets of creation. It was 1962, and Hawking had just begun his PhD at Cambridge University, eager to prove himself. His friend, physicist Kip Thorne, recalls, "Stephen was starting to make a name for himself, but it wasn't yet obvious he'd go on to eclipse us all." However, it was during this time that Hawking began to notice something troubling. His movements were becoming clumsy. A visit to the hospital delivered a devastating diagnosis: amyotrophic lateral sclerosis, ALS. The prognosis was grim. The disease would relentlessly attack his muscles, leaving him completely paralyzed. Doctors gave him just 2 years to live. Hawking was only 21. The dream of unraveling the mysteries of the universe seemed shattered. "I had just been diagnosed with ALS," Hawking once reflected. "I didn't know if I'd live long enough to finish my doctorate." It was the darkest chapter of his life. His daughter, Lucy Hawking, remembers, "He became deeply depressed, unsure of what to do. At the time, he was struggling to even find a PhD topic, and everything felt bleak and hopeless." But everything changed when Hawking met Lucy's mother, Jane. Their love story became his lifeline. "Getting engaged and married to Jane," said Lucy, "was the turning point. It gave him hope and a reason to go on." With newfound determination, Hawking decided to devote his remaining time to the ultimate question: does the universe have a beginning? And if so, what is it like? At the time, the Big Bang theory suggested the universe had a starting point, but many scientists were skeptical. How could something come from nothing? Hawking was determined to find out. In 1965, his journey took a pivotal turn. He attended a lecture by Roger Penrose, a brilliant mathematician. From the back of the room, Hawking listened intently, asking sharp, challenging questions. Something Penrose said ignited a spark in Hawking's mind, a clue that would set him on a groundbreaking path. There's a hole in space where massive objects disappear. This mysterious phenomenon could hold the key to one of Stephen Hawking's boldest ideas. If matter can vanish into nothing, could it also emerge from nothing? This question might be Hawking's first step toward proving the Big Bang. But how can such a hole exist in space? The answer lies in the nature of gravity itself. Einstein's theory of general relativity revolutionized our understanding of gravity. It's not just a force of attraction, it actually bends space. Pedro Ferreira, a physicist at Oxford University, explains, "Einstein realized gravity wasn't just a force between objects. It was something far more elegant and beautiful. Einstein imagined space and time as a flexible fabric. Massive objects like stars and planets press into this fabric, creating dips. In a moment of genius, Einstein understood that gravity isn't a force pulling objects together. It's the result of these dips in the fabric of space-time. Picture a rubber sheet representing space. Now imagine placing glass balls on it. These are the planets and stars. The heavier the object, the deeper the dip. Here's an example. Let's say this coin represents Earth. If I send it rolling around a larger glass ball, representing the Sun, it naturally settles into orbit. The coin isn't being pulled by a force. It's following the curves of space-time, shaped by the Sun. This is gravity as Einstein envisioned it, the bending of space-time. But what happens when this fabric is stretched to its breaking point? That's when something extraordinary occurs. A hole in space opens up, a place where objects can disappear. This process begins when a massive star dies. As it collapses under its own weight, it becomes smaller, denser, and more intense. If the star is at least 20 times the size of our Sun, the collapse creates a drastic effect on the fabric of space-time. Ferreira describes it vividly. Imagine pressing down on the fabric of space-time with unimaginable force. At some point, the depression becomes so deep that it's like tearing a hole in the fabric itself. This is the birth of a black hole, a region so extreme that not even light can escape its grasp. And it's this mind-bending idea that could help Hawking explore how the universe itself may have emerged from nothing. Nothing escapes a black hole, not even light. These cosmic enigmas are formed when a massive star collapses in on itself, becoming so dense that it creates an unimaginably deep dip in space. Any object that comes too close is pulled in, unable to escape. At the very center of this black hole lies something extraordinary, a singularity, a point of infinite gravity. Roger Penrose, a brilliant mathematician, discovered this phenomenon and described it as a place where the rules of physics as we know them break down. As you approach a singularity, Penrose explains, space and time as we understand them simply cease to exist. A singularity is like a drain in space, a hole where everything that falls into it vanishes forever. But this raises a profound question for Stephen Hawking. Could the reverse also be true? If a black hole pulls everything into a single point, could there be a moment when everything sprang out from one? The Big Bang Theory suggests that the entire universe burst into existence from nothing, a singularity. Could this hold the answer to the ultimate mystery? In a stroke of genius, Hawking realized the solution. It was beautifully simple. If you reverse time, Hawking explained, a collapsing black hole becomes an expanding one. Instead of sucking everything in, a reverse black hole erupts, exploding outward in a burst of space, matter, and time just as the Big Bang predicts. Against a sea of skeptics, Hawking and Penrose proved it. The universe suddenly appeared from nothing, emerging from a singularity. The debate is over, Hawking declared. The universe must have had a beginning in time. This groundbreaking discovery, rooted in Einstein's theory of relativity, was a triumph. But time remained Hawking's greatest challenge, not just in understanding the cosmos, but in battling his own deteriorating body. Hawking had uncovered the origin of the universe, a tiny, dense point known as a singularity. But the mystery wasn't solved. What triggered the Big Bang? Why are we here? Where did we come from? Using Einstein's theory of relativity, Hawking had shown how gravity shapes large objects. But this wasn't enough to explain the universe's dramatic birth. Solving this puzzle would be the greatest challenge of his life, a race against the clock, as his body continued to betray him. When the universe was born, it was smaller than an atom, a tiny, incomprehensible speck. To understand how it grew into the vast cosmos we see today, Stephen Hawking needed a completely different kind of science, quantum mechanics. But there's a problem. Quantum mechanics, which governs the behavior of atoms and particles, is wildly unpredictable. Unlike the orderly rules of gravity described by Einstein's general relativity, quantum physics thrives in chaos. These two theories, one for the large-scale universe and one for the microscopic, are fundamentally incompatible. Physicist Kim Weaver at NASA's Goddard Space Flight Center illustrates this conflict. Think of this ball as representing the battle between general relativity and quantum mechanics. On the large scale, the surface is smooth, predictable, like gravity. But when you zoom into the quantum world, everything becomes chaotic. The larger scale laws no longer apply. In the quantum world, particles behave in bizarre ways. Electrons, for example, don't orbit neatly around the nucleus of an atom like planets around the sun. Instead, they pop in and out of existence, appearing randomly and even existing in multiple places at once. Gravity seems irrelevant in this chaotic, microscopic world. But Hawking realized something revolutionary. At the moment of the Big Bang, an immense amount of matter was crammed into a tiny space, meaning gravity had to play a role. Uniting these two opposing forces, gravity and quantum mechanics, became Hawking's ultimate goal. He sought a theory of everything, a single, unified framework to explain the universe's birth, and every force within it. If we could find the answer to that, Hawking once said, it would be the ultimate triumph of human reason. Hawking knew the clash between general relativity and quantum mechanics wasn't just theoretical. These forces also collide inside black holes. At their core, a massive amount of matter collapses into an infinitely small point, a singularity. Relativity predicts that nothing can exist on the edge of a black hole. Everything is pulled inward. But Hawking suspected that at the heart of this conflict lay the key to answering the biggest question of all: what triggered the moment of creation? According to quantum mechanics, space is never truly empty. At first glance, it may seem like a void, but at the tiniest scales, it's buzzing with activity. Physicist Kim Weaver explains, "To us, space looks empty, but on a microscopic level, it's alive with virtual particles pairs that blink into existence and annihilate each other almost instantly. These particle pairs are made of opposites, one with positive energy and the other with negative energy. They constantly pop in and out of existence, created by the energy waves in space. Normally, these particles collide and destroy each other as quickly as they appear." Quantum mechanics had long been established, but no one understood how it connected to the larger universe. That's where Stephen Hawking stepped in. Stephen had the extraordinary ability to take two seemingly unrelated ideas and ask, what happens when they come together? Hawking turned his attention to what happens when these virtual particle pairs form near the edge of a black hole, a region known as the event horizon. What he discovered would change our understanding of black holes forever. At just 28 years old, as his body continued to deteriorate, Hawking's mind remained sharp. In a flash of inspiration, he saw the answer. The behavior of these particles near a black hole is affected by their opposite energies. When a particle pair forms near the event horizon, the particle with negative energy falls into the black hole, while the positive energy particle escapes into space as radiation. Hawking explains, "What's fascinating is that the negative particle is pulled into the black hole, but the positive particle escapes its grip, releasing energy in the form of radiation. This radiation, now known as Hawking radiation, was groundbreaking. It proved that black holes aren't entirely inescapable. Something can escape their pull." The revelation shocked the scientific community. "When I first presented my calculations, they were met with disbelief," Hawking recalled. After all, by definition, black holes were not supposed to emit anything. But Hawking proved otherwise. By combining the gravitational pull of general relativity with the chaotic world of quantum mechanics, he showed that the two theories could work together. Welcome to Blesovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blesovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blesovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.